Hi everyone, this is Dr. Kristen Hess. Today we're going to talk about time value of money and a tool that you can use to solve compound interest problems. So first, what is the TVM Solver, time value of money solver, and how are you going to use it? So first, we need to know what time value of money is. Basically, the idea is you have money today. If you save it or invest it, it's going to be worth more in the future. Likewise, if you borrow money in the future, you'll have to pay back more. So that's the big idea. And to use our solver, you're going to need some information. You're going to need all but one of the following. So you're going to need to know the number of periods that you're saving or borrowing money. Is it 5 years? Is it 24 months? You need to know what your interest rate is as a percent. So you'd put in 5% if it's 5%. This is a little different than simple interest because the calculator is going to convert it to a decimal. You're going to put it in as a number. So 10% would just be 10. You would want to know the present value, the value that it's starting at. Payment is, are you making regular payments? What's the future value? How often are we compounding, and how many periods per year? So let me give you an example. It's a little easier to follow once you see what's going on. So let's say that you have $1,000 and you're going to put it in the bank. And the bank gives you a 3% interest rate that's compounded monthly. So how much money will we have after 1 month? How about 6 months? How about 5 years? And then here's a new question. What if we have the same situation with $1,000 at 3%? But what if instead of compounding monthly, it's only compounded quarterly? So let's start looking at these questions together. I'm going to start by showing you the solver. So this is our solver. If you look in the comments on the video, there's a link to it. And so we're going to fill in the information from the problem. So I'm going to kind of go back and forth between the problem and the solver so that you can see what we have going on. So we have $1,000 at 3% interest. So let's start with $1,000 and 3% interest. So we'll type in $1,000. That's how much we have today. So that's our present value. And 3% interest. Okay, so let's go back to the problem and see what other information we are given. So it's compounded monthly, and we want to know how much money we have after 1 month. Notice the problem doesn't tell us anything about the future value. It doesn't tell us anything about payments. We just want to know how much money we have after 1 month. So that means we're going to assume that there are no payments. So we're going to keep payment at 0. The future value is what we're going to solve for. Periods per year, because it's monthly, there's 12 months in a year. And compounding per year, because there's 12 months in a year and we're compounding monthly, it's going to be 12. Everything you're going to see in my class, these two numbers are going to match. And so you're going to read the problem and look for a keyword like annually or a monthly or a daily or weekly or quarterly. And take those words and convert it into a number. So monthly would be a 12, quarterly would be a 4, annually would be a 1. So PY and CY are going to match. And it said 1 month. And so N is our number of periods. Because we're in months, we are going to put in 1 for 1 month because the problem said for 1 month. And now we'll solve. And so after 1 month, compounded monthly at 3% interest rate, you'll have $1,002.50. You don't need to worry about the negative sign. It has to do with the fact that you started by putting in money and then you take it out. And so one's going to be positive, the other's going to be negative. So let's go back to the problem and look at the next part. So how much is it going to grow after 6 months? So we're going to go back to the solver. So we still want to find the future value. So what has changed? Well, we're still compounding monthly, so the PY and CY are 12 because there's 12 months in a year. That didn't say anything about payments, so the payments are going to stay at 0. We still started with $1,000. We still have an interest rate of 3. The only thing that changed is now we're looking at 6 months. So we'll click on solve for future value. Notice that the second decimal place is missing, so you're going to need to click on that to see how much you have. So in this case, we have $1,015.09 when it's compounded monthly for 6 months at 3%. And we'll go back to our problem. And now 5 years. So we'll go back to the solver. So again, we're going to solve for the future value. Still being compounded monthly, we're still looking for the future value. The problem still didn't say anything about payments. We still start with $1,000, 3% interest rate, but now we're in 5 years. So we're going to take 5 times 12 because it has to be in months because we're looking at monthly. So we're looking at 60 months and we want our future value. So in 60 months, $1,000 would grow to $1,161.62 at 3% interest rate. Okay, let's go back to our problem and look at the second part. So we're going to redo the problem, but instead of compounding monthly like we did in the first part, now we're going to compound quarterly. And we're going to look at 1 month. So let's look at the solver and what do we need to change if we're compounding quarterly for 1 month? So quarterly first means that there are 4 periods in the year. So we're going to solve for the future value. Now 1 month needs to be turned into a quarter. Now a quarter of a year, so 12 months divided by 4 is 3 months, but we only have 1 month. So we have 1 month out of a quarter, which is 1/3. And so now we can solve for the future value. Okay, let's look at the second part. So what if we only compound quarterly for 6 months? So how many quarters are in 6 months? Well, 6 months is half the year, so that's going to be 2 quarters because there's 4 quarters in the year. So here we're going to change into 2 for 2 quarters, and then we're going to delete this and solve. We still have a 3% interest rate. We still started with $1,000. We're compounding and we have 4 periods per year because it's quarterly. So now we'll solve for our future value. All right, and the last one is what if we compound quarterly for 5 years? So before we can do anything, need to figure out how many quarters are in 5 years. So we know that there are 4 quarters in 1 year. So that means there would be 8 quarters in 2 years. And so we'll take 4 quarters times 5 years is going to equal 20 quarters in 5 years. So now we'll go back over to the solver. And so we'll change our n to 20 quarters because that's how many are in 5 years. The interest rate still stays at 3%. $1,000, no payment. We still have 4 periods per year, 4 quarters per year, and we're still compounding 4 times. Remember, these two you want to match. And we'll click on our future value. We don't need to click on it because we can already see both decimal places. And so $1,161.18 is how much that we'll have after 20 quarters. All right, I'm going to go back to the slide now. Okay, so I want to talk about the answers that we got. So these are all the answers that we got, and I want to talk about what it means. So first I want to talk about the difference between compounding monthly and compounding quarterly. Notice that in each case, when you compound more often, So when we compounded monthly instead of quarterly, it's a little higher. In the case of, we did 1 month, but in the case of 3 months, you have 52 cents instead of 51. In the case of 5 years, by compounding more often, so 12 times a year instead of 4 times per year, you end up with a little bit more. Not much in this case. In this case, it's just a few cents. But when you have bigger interest rates and longer periods of time, the more frequent compounding ends up with higher returns. Also look that the longer you keep the money in, the more it grows. So the 3 months, you get $7.52 in interest. After 3 months, you get $15.09. And after 5 years, you've got $161.62. So the key to growing money is having a good interest rate and having time to keep it there. 3% is just kind of keep up with inflation rate. So it's better than nothing. Okay, so let's continue. So in summary, we talked about the time value of money solver, what each of the variables meant, the FV, the PV, the PMT, the CY, the PY, and gave you an example of how to use it in a couple different situations. So now I'm going to give you an extension problem to do on your own. Let's say we still have $1,000. We put it in the bank account. We still have 3%, and we're going to compound it daily instead of monthly or quarterly. So how much money will we have after 1 month? How much are we going to have after 6 months? What about 5 years? So pause the video right now and try it on that solver and see if you can get the answers. And then once you have it, write it down, make a table, come back and check your answers. Okay, so this is what I put into the solver for each of those. So notice here, I'm going to point out some key things because it's easy to make mistakes here. So notice that our N for 30 days is 30 days because we're all daily. 5 years, we took 5 times 365, and then the 182 we were given. The other thing to note is down here, the PY and the CY, those are 365. That's going to be the standard number you're going to use with daily compounding. So you can also notice how the money gets bigger with more time. And if you compare it to our answers from the previous examples, you'll know that by compounding more often, this number is bigger than it was when we compounded quarterly or monthly. So thank you for watching. Let me know if you have any questions. Keep up the great work, everybody.